Hello everyone, let's talk about geometric mean versus arithmetic mean once again. So this is the kind of problem where geometric mean can be really helpful. So if you look into the problem, there are two investments which are being compared in this problem. For 6 years the investment A gives these returns. That means these could be the probable returns, or they could be like some kind of investment on the fixed return is going to be there. So or these could be expected returns. So returns on investment A for first year are 12%, -3%, 8%, 15%, 0%, and 4% subsequently. Similarly, in investment B, the returns are given. Now, the question is that which of the investments have a higher average return? So, I'm going to write as a higher return. Either it is investment A has a higher return or investment B, or I would just say that which has a average higher return. So I'll just modify a bit, average higher return, whether it's investment A or investment B. So I just want to know that which answer is correct. So I'm going to give you two options here. Option A is investment A and option B is investment B. So which option need to be ticked, that which has a higher return, whether investment A or investment B. Now since it has been asked about average, and as far as the knowledge of average goes, a lot of people use arithmetic mean when it comes to average, but this is not the case where arithmetic mean is going to be fruitful. So let's compare these two things, how the two different averages can differ from each other. Let's calculate the arithmetic mean. So I'm going to calculate arithmetic mean for investment A. That means what is the average return for investment A, and the simple concept of arithmetic mean I'm going to use. So I'm going to use 12% plus -3%, and then it is going to be plus 8% plus 15% plus 0% plus 4%, and then I'm going to divide it by number of years. That's what the formula of arithmetic mean is, sum of values divided by count. And when I solve this particular problem and I get the arithmetic mean of 6%, that means arithmetic mean suggests that investment A is going to give me a 6% return at the end of 6th year. Average return every year 6%. I'm sorry, not at the end of last year. Now I'm going to calculate arithmetic mean for investment B. I'm going to use the same process once again. It's going to be 50% plus -40% plus 30% plus 70% plus 10% and plus -50%, and that is supposed to be divided by again 6. And when I solve this, then I'm going to get 11.67%. So arithmetic mean clearly suggests that investment B is going to give me higher returns. Now let us see what geometric mean suggests us. You can refer to the previous video. I have already told you that when you are calculating geometric mean in such situation where the rate of change is mentioned, then formula number 3 is the formula which you need to apply. 1 plus x1, 1 plus x2, and so on, and -1 at the end. And if the terms are given in percentage, you can simply convert them into points. That means 100% can be considered as 1. So 3% will become 0.03, and 30% will become 0.3, and 70% will become 0.7, and so on. So 100% can be converted into 1. So let's apply formula number 3 in this particular problem. I'll try to show both the things. I hope it is visible. Okay. Or now let's use the geometric mean now. So I'm trying to keep formula 3 in focus. Let's calculate geometric mean for investment A first of all. So I'm going to calculate geometric mean here. Geometric mean for investment A. So let's see how the formula goes. It is 1 plus x1. Now what is x1? It's 12%. So I'm going to write it 0.12 times 1. Now plus, and here it is -3%, so it will get converted into -0.03 times 1 plus 8% is 0.08 times 1 plus 15% is 0.15 times 1 plus 0% is 0 times 1 plus 4% is 0.04, and that is supposed to be raised to the power, since there are in total 6 items, 1 by n. 1 by n is here, so I'm going to raise to the power 1 by 6 minus 1 at the end. Now I'll use a calculator simply to calculate this whole stuff rather than going for log table. If you want to go for log table, you can see my previous videos. So I'm going to use a calculator here, and so I'll just start with the bracket, and let's start with the bracket here, and then it is going to be, the first is 1 plus 1.12, so it is going to be 1.12 times 1 minus 0.03, which is going to be 0.97, and then the next term is 1 plus 0.08, so it is going to be 1.08 times the next term is 1 plus 0.15, so it is going to be 1.15, sorry, it is supposed to be 1.15, and times the next term is 1 plus 0, so it is going to be 1, and then the next term is 1 plus 0.04, so it is going to be 1.04. 1 2 3 4 5 6, I have included all 6 terms, is equal to, so this is the value which I get. So I'm going to put it in the bracket here, 1.4032, okay, I'll just take up to this much, raised to the power 1 by 6 minus 1. So okay, the focus is lost. Okay, I put the term back in, 1.4032 raised to the power 1 by 6 minus 1. So this is the value right here. So what I'm going to do next is I'm going to calculate the power 1 by 6. So I'll use the x raised to the power y function right here, and the raised to the power 1 by 6. So that gives me 1.058097. So it is going to give me 1.058, and that's it. I'll keep it, okay, 09 after that, so you can also say that, and then subtract 1. So I'm going to subtract 1 out of it, so minus 1, that gives me 0.05809, so I can write it 0.0581. So I'll write it 0.0581. If I convert it into percentage, I multiply it by 100 and it gives me 5.81% return. So you can compare both the things here, where arithmetic mean was giving me a 6% return on investment A, the geometric mean is giving me a return of 5.81%. Now same way I'm going to calculate geometric mean for investment B. And how it is going to go, same way, it is going to be 1 plus 50% is 0.5 times 1 minus 40%, so it is going to be minus 0.4 times 1 plus 30% is 0.3 times 1 plus 70% is 0.7 times 10%, that is 1 plus 0.1, and then the last return is 50%, so it is going to be 1 minus 0.5 raised to the power 1 by 6 minus 1. Now if I do the same way, means I calculate the things same way, which exactly I explained a moment before, you can refer to the first particular part of it, then I get the geometric mean of it as 1.51%. So if I go by geometric mean, then simply it suggests me I should go for investment A, which is giving me a 5.81% return. When I go with the arithmetic mean, it suggests me I should go with investment B. Now you can use a simple arithmetic, so I'm leaving this problem open. You can use simple arithmetic to calculate that if you invest rupees 100 here and rupees 100 here, so don't use average return, just use the same returns every year. you can lean back to the mathematics of class 8th, and you just see that which gives you the higher returns, and you will definitely end up that investment A is a better choice here, because geometric mean is telling you that it is giving you a higher return. So the correct answer of this problem is that one should go for investment A, not for investment B, which was suggested by arithmetic mean. So that is another problem which compared arithmetic and geometric mean, and whenever I'm talking about rate of change, rate of growth, decay of something like this, then geometric mean always gives me a better result. Thank you very much.